Hi, I'm Captain Adam Orton with the Canadian Army Podcast. So, right off the bat, I'm going to define CBRN because we're going to have to say it a lot, and that's chemical, biological, radiological, and nuclear. We usually see these things as part of the main plot point in the Destroy the World movies. Here to talk to us about how to deal with the fallout of these incidents is Lieutenant Colonel Jonathan Hubble, the director of Joint CBRN Defence, which basically takes care of doctrine, equipment, and all the things that have to do with CBRN threats for the Canadian Armed Forces. Welcome to the podcast.
Well, thank you, Adam. I'm very glad to be here.
In general, CBRN stuff is pretty dangerous stuff. These weapons have been around for forever. A lot of it can be war crimes, but what are the things that we're focusing on in these modern times for CBRN defense?
You know, we do take an all hazards approach. So in a way, what's important for the soldier is to know and have confidence in their protective equipment, for example. So we're hoping, obviously, and planning to prevent and protect against any kind of CBRN threat. We do focus on airborne threats, so the C4 gas mask, and we're actually replacing the C4 gas mask with the C5. It's being rolled out as we speak. These things are things that protect us from toxic industrial chemicals. They protect us from sarin gas, mustard gas, a variety of different threats, actually. So in terms of what we could face, in terms of specific things, there's obviously emerging concern over the nuclear threat with certainly the public statements that have been made by the Russian president. And that has certainly concerned our European allies at the CBRN level and at the operational level. I believe that there's a lot of concern about those threats in the European theater and where we're conducting Operation Reassurance, for example.
Can you maybe talk us through any recent notable CBRN incidents?
Right. So one of the recent uses of chemical weapons that we're aware of is a few years back in the UK, there was an attack against an individual using fourth generation chemical warfare agent. And this is something that's basically like a highly poisonous substance that was supposedly targeted against an individual. But based on the lethality of the substance, it became quite an operation within the UK to conduct decontamination. So quite a lengthy investigation, quite a lengthy and detailed civilian and military response. And I'm speaking about the Skripal incident in the UK.
Right. I remember it very clearly. Sergei and Yulia Skripal were poisoned with some sort of suspected nerve agent of some sort. I think it was Novichok.
Right. That incident is one. There's other incidents. These are traced to Russia and the use of basically chemical weapons.
Yeah, basically textbook CBRN incident.
Yes. And certainly an assassination type thing. So conventional threat, not exactly. But there is the weaponization of those substances is possible in a conventional setting.
So let's jump right into what all of the things mean. So let's start off with chemicals. These kinds of weapons have been around for some time now.
Right. Chemical weapons, chemicals are specifically developed for like a weapons purpose and actually kind of can trace their roots back to certainly First World War with the use of mustard gas and so on.
Yeah, and it really got out of hand in World War I. What did we do about that?
I touched on sarin and mustard. VX are all listed chemicals in the Organization of Protection Against Chemical Weapons, to which Canada is a signatory. So we've committed not to manufacture or use these in warfare, and hundreds of other countries have signed on to that. There's countries that haven't signed on to or are not considered to be respecting their signatories on that convention. So there's a number of listed agents that are still out there in terms of old stockpiles, and there is always the potential for new manufacturing and new weaponization of those chemicals.
Okay. What about biological weapons?
So biological is a very interesting space because when you have the first indications of a biological threat, you may actually not know whether we're talking about a manufactured bioweapon or whether we're dealing with a naturally occurring virus or bacteria or whatnot. So biology is its own sphere, which I'm personally not an expert in, but I can say that when we had the pandemic, for example, the COVID-19 pandemic specifically, at first, when things were unfolding, it was not necessarily clear whether we're dealing with a bioweapon that got out of hand or a naturally occurring virus, for example.
Right. And how would you say that's different from chemical? Like I know biological weapons are living agents and chemical weapons are not alive, but I would say I've had some interesting conversations recently about that subject. And, some people are like, oh, it's kind of the same thing, right? They're manufactured things that you may inhale or touch, and then you get sick.
Like one of the big differences obviously is in detection. Like the technology of detection is going to be very different and the sensors are going to be different. So in CBRN discipline, detection, identification, and monitoring is a key component where we're looking to define a hazard and stay away from that hazard and protect ourselves against that hazard. So the technology that detects bio threats is different than the technology and the sensors. So if we go to Suffield Research Center, which is where CAF and D&D does cutting-edge research and development in the space of both counter bio threats and counter chemical threats, they're going to be working on different types of sensors to achieve as much standoff and warning to the soldier as possible to give them time to either evade the threat or protect themselves against the threat.
And then we have nuclear and radiological, which also seem very similar. What are those threats?
Right. So radiological and nuclear differ in just the sense of you could have weaponized radioactive material that is not a nuclear weapon. So a nuclear weapon would be designed and engineered for an attack as a offensive weapon. We're talking about intercontinental ballistic missiles, nuclear warheads that are payloads designed for militaries, essentially. Then radiological threats could be, a wider spectrum of more asymmetric radiological material that could pose a hazard. And often the response in terms of what we're doing is going to be similar in terms of detection, identification, and monitoring. We're going to want similar sensors, but they may be different in other respects. For protection, we would be looking probably at similar types of protection levels that protect us against radiation.
Yeah, and I would guess detecting a nuclear blast is generally pretty easy, but invisible dirty bomb radiation is probably pretty hard.
So one of the capabilities that we have in this area is a software called Joint Effects Modeling.
Okay.
And this software allows a CBRN analyst in a collection center to take a potential threat and model what would happen if this weapon exploded in a given area. So they can then take weather data and take temperature data and all that and put it together with the effects that are known for specific weapon systems and then predict hazard areas. And they would use this to inform commanders on responses in terms of risk mitigation and force protection levels that need to be adopted.
These things, biological, chemical, and nuclear, all have vastly different signatures and vastly different mechanisms of action in terms of harming people. How do you come up with protection against such a wide spectrum of things in the context of what we're talking about, and also detection methods?
Yeah, with detectors, we take the approach of developing by chem, bio, rad, essentially. So each of those will have their own detectors. But once within bio, you want a bio detector that detects as many bio threats as possible. And same thing with the other areas of the discipline. With respect to protection, you do get into trade-offs. So one of the key trade-offs is the thermal burden that is applied to the individual. So everybody knows, well, a lot of soldiers would understand why we don't train for long periods of time in a CBRN suit. It's because of the ergonomics and the thermal load, which we are actively working through our minor capital projects and even our next generation low burden individual protective equipment project, which is a major capital project. We are looking at ways to reduce that thermal burden. In other words, make protective equipment or clothing more ergonomic. The issue, obviously, is you make trade-offs, and so you won't have a suit necessarily that protects you against radiation to a high level if it's also going to protect you against chemical, and it's also going to have a low burden for ergonomics. So in that whole space, we will have to make some choices. We have, in the past, focused on chemical threats, because of the prevalence of tactical chemical weapons that our adversaries possessed in the past. But in the future, we may have to have multiple suits that you pull off the shelf based on a toolbox approach. What is the current threat?
And this brings up everybody's favorite topic of conversation, which comes down to kit. And I think it's fairly well known that throughout the thousands of years that soldiers have been doing soldier stuff, that your average weight for a soldier is about X pounds, whatever that is. I think it's something like in the 65 to 70 range.
Right.
And so you're constantly doing the dance of what that amount of weight is for body armor, CBRN equipment, weaponry, et cetera, et cetera, et cetera. And it's this constant dance of making sure that you have everything that you need while at the same time still being able to travel and not run out of steam to get there and then do the fight.
Yeah, I mean, I think with the CBRN equipment, it's generally, based on the threat level, we push that equipment to the echelon that it needs to be at. So if it needs to be right on the soldier or right in the rucksack, then that's a pretty high threat level because of all the other things that are in the rucksack that are dealing with other threats like, ammunition and NVGs and all those things. So luckily, in the recent past, we haven't had to burden the soldier with a CBRN suit in their rucksack. But it can be, at their CQ, at their company quartermaster, not far away, a couple tactical bounds away, and in time and space, not that far away. But that's why we're looking for standoff and warning time through sensing, through knowledge management, through our networks, and basically situational awareness so that we're not surprised. And if there is going to be something that's coming, that we have time to prepare.
There's something to be said about the value of having the equipment on hand, but there's other protections, like just generally being aware of what capabilities the enemy has. And that works both in the CBRN sphere and also in conventional warfare, like, whether it's weapons range bands or types of equipment and so on.
Yeah, and one of the protective layers that I didn't actually have any idea about before I got into this job was the medical countermeasures. So there's a whole stockpile and there's a whole system of medical countermeasures where they've done a threat assessment. They've figured out what chem threats, what bio threats are kind of most prevalent, for example, and they've purchased and they stockpile medical countermeasures. So if you're going into a specific theater with a higher threat, in some cases you'll be deploying with medical countermeasures. And those are sometimes pre-exposure, and in a lot of cases they may be post-exposure, but they're designed to preserve your life and to bring you back into, recovery. So, we think of the suits and we think of the masks, but there's another layer that is pretty important as well.
So when I think about CBRN, we're kind of talking about is like running around with a gas mask on and you're just huffing and maybe your goggles are fogging up because you're wearing this rubber thing on your face. And it's really difficult sometimes to work with this stuff. You were talking a little bit about balancing combat effectiveness with protection. How do we examine that?
It is probably the number one modernization agenda, I would say, of the next generation of physical protection equipment is to reduce the burden. So with the C5 mask, they did reduce the burden. So they reduced the breathing burden. So you know how you have to use extra force to breathe in through C7, C8 canister? Now with the C5 mask, that burden is reduced. So it takes less effort to breathe in with that mask. And there's other kind of ergonomic improvements in terms of what you can hear in the mask with the sound system and what other people can hear from you with a bit of amplification. So there's some important improvements to the C5 mask. And we're doing the same idea with the materials that we're going to use for any suits and anything that the soldier has to wear on their body. We're very much considering thermal burden and ergonomics as one of the key deciding factors. I mean, protection levels as well, because you don't want to reduce protection levels. But at some point, you need the soldier to be able to operate for a certain amount of time.
I feel like since we're talking about kit, let's talk about something real quick that near and dear to a lot of people's hearts up until recently, beards.
Right.
What's the deal with beards and gas masks? Do you have any searing insights on that?
Yeah, so we've looked at that. We are studying it. So a few years back, we had direction and guidance to consider all faces and people with bona fide or legitimate religious accommodations with turbans and beards that are there for religious reasons and so on. So we, working jointly with DRDC, developed a project called the C5 Bravo mask. And that's based on the C5 mask, but it's a mask that's intended to have a proper seal without necessarily requiring a shaven face that fits a certain mold. So right now it's based on a hood pattern. The hood kind of melds with the mask and you get a whole body seal essentially that keeps things out. That mask is still in early stages of development, but there's another solution that has been tested and I believe we have confidence in it. It's a PAPR solution, and it's a little air blower that fits onto your mask and creates positive pressure on your mask. And what it does is instead of air filtering in through the leaks, air filters out through the leaks. So this has been used successfully at Canadian Forces Leadership and Recruit School for people that don't have a good mask seal with their C4 mask, for example. And it can be used in operations as well for that same purpose. So there is another solution for people with beards, for example. You can shave if you need to, and if it's going to save your life. You know, military leadership have said that, and they've preserved those regulations in the CF dress manual, and the CAF has reserved the right to tell people to shave for life-saving purposes. But at the same time, we're actively pursuing equipment solutions to reduce the burden on people that have legitimate either physical reasons and differences or religious or social reasons.
You know, it's interesting about the different approaches that we use, because for anybody who's even been exposed to something like CS gas as part of our training, it's not a great time if you don't have a good seal. That's what I'll say. And people really sense it. And I think one is well motivated to create the conditions for success, particularly when exposed to highly dangerous items too.
Yeah, absolutely. I mean, I remember last year, you remember when we had the wildfire smokes here?
Yeah, of course.
You know, that was a time when you stopped taking clean air for granted and you start saying, well, okay, like, what's the right mask to wear here? Because clearly just breathing in, you know, particulate matter is not the best idea here. So I think people are really fond of clean air.
Yeah, that's one way of putting it. So, you know, you've got your regular everyday big nuclear bombs that can level a city, but we also have conventional civilian attacks like subway gas attacks and things like that. In terms of our role, the military's role, how do we balance that with civilian infrastructure and natural events like, you know, radiological incidents and nuclear power plants and so on and so forth? Where do we fit into that?
For one thing, it's all a civil military problem. I'm not aware of too many disasters that happen that don't have both a civilian response and some level of military response. Even the pandemic, we look back and we had, I would say, a significant military response to in a civilian-led environment. And my CBRN counterparts in Europe are proposing very clearly that they see an equal partnership between civil and military in terms of response to CBRN incidents. It's going to be disaster management, it's going to be risk mitigation and hazard mitigation in a kind of whole of government approach.
What other resources exist outside of our structures that we would connect into?
I'm thinking of especially a first responder concept where, you know, firefighters, if you look at,
of course.
I wasn't at Chernobyl, but I watched the Netflix series. You know, the first folks that get the call to go check it out and go do something about it are the firefighters. And they are protected to a certain degree, certainly now more than they were then, but they have detectors, they have the ability to sense a little bit and do situational assessment. And they also have reach back, so they can, you know, take samples and figure out what stuff is. What we don't want to happen is, you know, people sensing by falling down and becoming casualties. So we want to make sure that within the CAF, in terms of first responders within the CAF, our health services, our MPs and so on, we want them to be equipped. And then within the larger structure, we would expect that we would fit into as second responders. So there'd be, within Canada especially, there'd be a civil response initially, and then the military response would kind of fit into that. But we would need the same, or at least complementary capabilities and some level of mutual understanding to be able to work together. So the operational example of how we've kind of envisioned that is written into Contingency Plan Rubicon, which is the operational level plan that says, here's how we would assist the civil authority in managing a CBRN disaster. But that's just a contingency plan that changes once an actual incident happens, because everything becomes specific to the province, the municipality, the type of incident that occurred, et cetera.
Of course. Just like COVID, really.
That's right.
So that's the planning side of the house. And, you know, we also have exercise precise response, which is basically the Canadian Armed Forces led major CBRN specialist response. You've got a bunch of allied countries with NATO using live agents. But for us, for military members, CBRN is kind of like woven throughout our training. You know, usually when you're doing an exercise, there's always a bit about it. When you do your basic training, you cover it. We do annual refresher training. There's additional exercises that take place that focus more on it. And I was going to say, you know, Why is that ubiquitous? But I guess now that we're talking about it, it seems fairly obvious. But how do we incorporate that into our training, and why do we do it that way?
I think we've succeeded in weaving it into the initial training of the soldier at Canadian Forces Leadership and Recruit School in Saint-Jean. And I think we've succeeded in making sure that it's a baseline to go on deployment with the individual skills of the gas hut and so on. But I would say that in the last 5 to 15 years or even longer, as we went through a period of counterinsurgency fighting where there was, very high IED threat and maybe a lower CBRN threat, and then, a very conventional threat of firefights and conventional munitions threats, I think it's my perception and the information I have is that in collective training and training exercises that the amount of CBRN injects and task completion has been relatively low compared to historicals if we look back into, the 90s, the 80s, and before that. So it is interesting to hear your perspective in that regard. I think as we look at operational assurance, for example, and training in that theater and for that theater, I think it will be important. I think our allies will see it as important in the multinational context. And that's certainly what we've got from reading the NATO CBRN Defence policy from 2022, where they say that we need to train this, we need to be more resilient, we need to work harder and better at being prepared and also preventing and protecting and recovering from a CBRN threat.
When I look at maybe some of my training experiences and kind of how we talk about how chemical warfare happens, if there's a threat, like if there's an intelligence report of some sort of CBRN threat in your area, and then you see yellow smoke blowing towards you, it doesn't take a genius to figure out what that might be. Mm-hmm. What other mechanisms of detection exist so that people can see what's happening and take appropriate actions?
Yeah. For one thing, I happened to go visit the Comprehensive Test Ban Treaty Organization in Vienna, which monitors seismic activity across the world using acoustic sensors underground and other acoustic sensors. And the whole purpose of that is to make sure that if anybody tests a nuclear weapon anywhere, that it's not done in secrecy, that it will be known and it will be reported to the treaty organization. They have a great operations center. And as we were visiting the location, we're seeing actual seismic activity being reported. In this case, it was in Japan. It was naturally occurring, likely, low-level earthquakes that are constantly kind of happening there anyway. But at the very basic level, at nuclear detection, the CBTO tracks any explosion of any kind of size to the point where their sensors went off and reported the Beirut explosion, for example.
Right. That was a big one.
It was a big one. Yeah. And so Canada is actually part of that. NRCan, National Research Council Canada, receives that data, and our intelligence folks are able to absorb that data if they need to as required as well. So, but that's at the kind of strategic global level, really. When we get to the tactical level, we are about to purchase a chemical agent sensor that does standoff detection. So the gas cloud you talked about, we're looking at purchasing an optical type sensor that's going to see that cloud at 5K or line of sight, detect it, a warning goes off, and then a computer system and a duty officer are reporting that and then sending out force protection advice to commanders on the ground that are going to then either, protect themselves or evade the threat.
You got to appreciate then that seismic thing that you just described. It tells the story of the bigger intelligence picture, which is it can be really hard to hide these things because there's all sorts of indicators. You have weapons labs, you've got scientists, you've got big facilities, and all of these things are advanced warnings that the enemy has some type of CBRN weapons. So you kind of know something before a cloud of gas is hitting the troops.
So we're absolutely trying to take an approach where the soldier is not the sensor.
Right. Well said.
And we're in a sensor-rich environment. There's satellite coverage of the entire globe. There is, like I mentioned, the seismic coverage of the globe. There's sensors everywhere. Our capability that we have is called Sensor Integration and Decision Support. And that's a software system that links our computers with our sensors and allows a CBRN analyst to receive NATO reports for strike warnings, hazard warnings, CBRN reports that are specific to incidents that have occurred or are expected to occur. It allows us to do what you just mentioned, which is make sure that we know what's happening around us and turning all sensor data that are picking up clear indications or indications and making that usable for commanders on the ground.
So with all of these things that we've talked about up to this point, what has grasped you the most about kind of what you've learned over your time dealing with these materials? Like, what's the key takeaway here?
I think an ounce of prevention is worth a pound of cure with CBRN. So in other words, a little bit of training goes a long way. A little bit of equipping goes a long way. Zero equipping and zero training is not a great option.
Yeah, that's good.
So I think it's that prevention aspect of being prepared. And even though we wish these things will not happen, we look at the doomsday clock at, 1 second to midnight or whatever it is currently. And, these are the atomic scientists of the world telling us that we're close enough to disaster in a laundry list of things that maybe we should take time to be as prepared as we can be with the limited resources that we do have.
Hope is not a COA.
Hope is not a COA. That's right. Yeah.
Hope is not a course of action. It doesn't work. You got to work for it.
Yeah, that's right.
All right. Well, thank you so much, sir, for being on the podcast. Really appreciate it.
I had a great time. Thanks for having me.
That was Lieutenant Colonel Jonathan Hubble from the Directorate of CBRN Defence. And I'm Captain Adam Orton for the Canadian Army Podcast. Orton out.